All right, so welcome to the session, and I hope all of you guys are doing good. So let's get started with today's session. So this is the AI series which we are running from the past, and we had a discussion about artificial neural networks. We had a discussion about convolutional neural network. We talked about recurrent neural network as well, and in the last session we had a discussion about encoders and decoders. In today's session, we are going to talk about transformers, and as discussed earlier as well, that these sessions which we are conducting is for non-technical folks, those guys who are not coming from computer science background or having least knowledge of coding and all. So this is more like a understanding of what these concepts are, and at the same time, uh, basically what's going on under the hood in these type of architectures. So let's start with the session. So first of all, why transformers matters. And again, I tried this PPT to create in a way that you can understand it very easily. A lot of examples I have put it in, and we'll try to go through all these. So the age of generative AI. So the analogy is, imagine talking to a robot that not only understands you, but also responds like a real human. That is generative AI. Generative AI tools like ChatGPT, Delhi, and Google BART are everywhere. They can write poems, create images, answer questions, even code, and they do all using something called transformers. So we are using all these stuffs on a daily basis now quite extensively. But what is the reason behind this? Why it is happening? How it is happening is what we'll try to understand in the next PPT, next slides. Just like electricity powers your home, transformers power generative AI. So now let's try to break down the entire history of AI, I can say. So initially they came up with the rule-based AI where I have certain rules, and if I follow the rules, I will give certain output. If I am not following the rules, I will not give that output. I will give some otherwise. Traditional machine learning models where it is trying to learn the patterns and from that patterns trying to do some predictions. After that, all the artificial neural networks coming in, all the neural networks coming in rather. So RNNs are there, LSTMs are there. So which has a better memory, but still forgetful and slow. So these are the challenges which we had. And in 2017, the paper came in, which was Self-Attention is All You Need. That is the paper name, and it was published on 2017. And this is giving the model superpowers to focus on most important parts of what you say instantly and accurately. So before Transformers, AI was like someone reading a book with one eye closed. Now it is like wide open, both the eyes. So imagine you are telling a story to a group of kids. One smart kid remembers not just the last sentence, but the whole story so far and knows which part is most important right now. That's how Transformers works. They pay attention to everything and decide what matters. If you are coming from the traditional neural networks, so it is trying to focus on what they are actually, as of now, seeing the data. But in the transformers, what happens is that it is consuming the entire data, trying to understand the importance of that data, and based on that, it is responding. That is the biggest difference which we have with other networks and transformers. They are not like older models that read one word at a time and forget what came before. Right. So this is the benefit which we are getting in the transformers. What can transformer do? Transformer can do anything which we are using quite extensively these days. Like we can create chatbots, we can have language translations, we can have image generation, summarizing articles, auto code generation. These are the various things which we are doing it. Obviously, video creations and all those things are also there. If it talks, writes, draws, or codes, there is a good chance a transformer is behind it, right? It's a very, very nice invention, I would say, and very, very powerful invention, which is making things quite simple for various different type of tasks. The big idea behind transformers. So let's say you are reading a mystery novel. You don't just remember the last sentence. You remember important clues from earlier pages to figure out who did it. A transformer is like a reader who always knows what part of the story matter, no matter how far back they are. A transformer is a type of AI that reads text, understands it, and generates smart responses by paying attention to all the words at once, not just one by one. Right. So here is the example which you can see. So key idea, not all words in a sentence are equally important. Let's say you are reading the cat sat on the mat because it was tired. Now what does it refers to? The cat or the mat? So a transformer figures out by using attention. So there is a concept of self-attention, and that is the concept it is using under the hood. It looks at every word in the sentence and decides how relevant each word is to the one it's focusing on. Think of attention like a magnet. Each word pulls that model's attention more or less strongly depending on how important it is in that moment. Right. So that is the key thing which is happening in the transformers. So there is a concept of attention mechanism, and that is what they have implemented. So in the transformers, there is no LSTMs. Like in the encoder and decoder, we had the LSTMs and all, but in the transformers, transformer consists of encoders and decoders, but it does not have LSTMs inside that. So why not older models are important, or I can say not able to solve the problem. So older models like read text one by one word at a time. However, transformer looks at the entire sentence together. Older models struggle with long sentences and transformer handle long texts easily. Older model forget earlier words. Transformer remember everything at once. Older models slow to train and transformers are fast and parallel. Transformers don't walk through a sentence, they jump around and connect the dots instantly. And that is the benefit which transformer is giving us. And because of that, it is giving us more power as compared to the normal AI models. Imagine you are in the class and teacher asks you, why did the boy cry in the story? You will recall the entire story and you can say, recall the boy's puppy ran away. Ignore the paragraph about weather. Focus on the sad part, right? So that is what transformer does. That's attention. You remembered the important part and ignored the rest. Transformers do the same when reading. They focus on relevant words, right? The name comes from how it transforms the input text, what it reads, into output text, what it writes, through layers of understanding and attention. Think of it like input, then transformation layers, understanding, and based on that, the output is coming in. So this is the key concept of transformer. Transformer is like a model that reads and writes smartly. Attention, the skill to focus on right words. Advantage, fast, smart, and handles long sentences. And the analogy is like reading a book and always remembering the important clues. Right. Now we'll talk about the building blocks of transformer. So this is the actual architecture of transformer. By seeing the picture, it is looking very, very tough that what it is and what's going on. So you can see there is an input embedding, positional encoding, multi-head attention, add and norm, feed forward network. Again, we have add and norm. And after that, we have the right part, which is the output embedding, positional encoding, and so on. So left part is actually known as encoder and the right part is known as decoder, right? So it is again an encoder and decoder architecture, but inside this encoder and decoder architecture, they are not using LSTMs or RNNs. They are using the self-attention mechanism. So think of a transformer like a smart machine built from 6 main parts. input embeddings, positional encoding, self-attention, multi-head attention, feed-forward layers, normalization, and skip connections. We'll try to get into detail. Again, as I mentioned, this session is more for non-technical folks, so I will not get into the detailed mathematics of the same, but I'll give you the idea that what it is and how it does. So let's get into this. So input embedding, turning words into numbers, right? Machine is not meant to play around with the characters, the alphabets. Machine can only understand numbers. And I want to convert that particular sentence which I am passing in into numbers. So input embedding is nothing but uh, converting the entire text into numbers. For example, hello might become some vector, right? So there's a vector which you can see 0.21, 0.67, 0.14, and so on. This number format is called an embedding. It's like a unique ID card for each word, showing its meaning in number form. The analogy is something like imagine each word is like a fruit. An embedding is a barcode for that fruit that includes the taste, color, and size. Basically, all the important information which I can get from that word, I will store it in the form of a number. So that is your input embedding. The first layer which you can see in again in this particular picture as well. The first layer which is input embedding, which you can see here. So that is the first layer which we have. Next is the positional encoding. Now, when we are passing a sentence, I am very much interested to understand what is the sequence of the sentence, right? Sequence matters, right? For example, the dog chased the cat is not equal to the cat chased the dog. Both are different, right? So the sequence of the sentence is important, and positional encoding is basically doing that. Which word comes first, which word comes second, and all those things. It is generating the encoding for the same, which is helping them understand that which word is having which sequence. So word meanings depend on the order, but numbers alone don't carry position. Transformers add positional encoding to tell where a word is in the sentence. The analogy is something like think of embedding as a puzzle piece. Positional encoding is the label that says which piece goes where, right? So that is the second part of the architecture, which is positional encoding, what it is doing. Third is the self-attention, very interesting concept. This is the key concept which they have implemented in the transformer. Remember this sentence, the lion roared because it was angry. How does the model know it is equal to lion? Self-attention helps each word look at all other words and decide which ones are important. It's like a group chat where every word listens to others and figures out who it needs to pay attention to. So that is the biggest innovation they have come up with, and they have implemented that. One more concept which we have is multi-head attention. Now, instead of one self-attention mechanism, transformer use many at the same time. Each one looks at the sentence from a different angle. One might focus on subjects, one might focus on verbs, another might track emotions or relationships. It's like looking at a painting under different lights to see different details. So multi-head attention is something like I can say as a layman, for example, I am sitting in the river bank or on the river bank, something like that. So bank is not the bank where we are depositing the money. It's a different concept altogether. It's a different meaning altogether. So all those things are taken care by multi-head attention. Basically, one word can have multiple meanings. So what it meant is what this multi-head attention will try to understand. Right? What is the idea of that word? So that is the multi-head attention part which we have in the architecture. Then there is a feed forward layer that is thinking deeply. So after attention decides what matters, we pass the information to feed forward neural network. It's like a mini brain. It helps the model think, abstract, and understand context, adds depth to its thinking, like reflecting on a conversation and draw a smart conclusion. So feed forward layer is helping me to generate the responses based on what inputs we got, right? Residual connections and layer normalization, keeping things balanced. These are stabilizers that make sure the model does not forget original information, does not become too biased or overwhelmed. Like guardrails on a mountain road, they help the model stay on track and not lose control. Right. Now here's the full transformer architecture, which I'm trying to explain here, which is like combination of encoder and decoder. So encoder slash decoder layers output text. So basically we are getting the input. We have the encoder decoder layers, and then we are getting the output. Imagine like a translation factory. The encoder reads and understands the input. The decoder generates a response based on what the encoder understood. Think of a transformer like a smart translator. Listens carefully and takes notes. That is your encoder. Reads those notes and speaks in another language or gives a reply. That is a decoder. The encoder is a stack of layers that takes embedded words, adds positions, use self-attention to understand word relationships, passes that understanding through feed-forward networks, repeats this multiple times in layers. Analogy, like rereading a paragraph multiple times to understand it deeply, and the output is a rich, multi-dimensional understanding of the input text. Now the decoder part, right? So the decoder is also made of layers, but with a twist. It looks at what it has generated so far. It uses masked self-attention. So basically masked self-attention is nothing, but it only sees previous words, not future ones. Then it looks at the encoder's output to know what the input meant. It uses multi-head attention plus feed-forward layers to generate the next word. Like painting a picture stroke by stroke and checking the sketch for guidance. Right. So basically it is generating the output, and at the meantime it is checking the encoder as well, whether the output is actually coming correctly or not. Right. So that is the decoder part does. So that is why this masked self-attention is coming in. Only sees previous words, not the future ones. Right. So it checks all the previous words from the encoders and not the future ones, and then generates the output. Here is the example. Now there are different types of models we have, like encoder and decoder model, like Google Translate, translation English to French, text summarization, question answering, input full sentence in one language, output full sentence in another. Real life examples are TF and BART. These are some of the models which are encoder and decoder only models. Like basically both the concepts are there. Encoder and decoder both are there in this. There is encoder only model as well. So if you remember that architecture picture, we had two blocks. One is in the left side and one is in the right side. So the left side is known as encoder and the right side is known as decoder. So there are certain models which they have developed, which is basically the only having the left part, the encoder part. So BERT is one of the models, which is encoder only model. And this type of model uses only the encoder part. It reads the full sentence and understands it deeply. Used for tasks like classification text, spam or not spam, finding answers in a passage, filling in missing words. So real life example is BERT, which is, as I mentioned earlier as well, which is bidirectional encoder representation from transformer. So that is why the full form is BERT, bidirectional encoder representation from transformer. Bidirection is equal to looks both left and right of a word to understand it. Right. So basically, if I am having a sentence, I will look the left part of the sentence as well, and I will look at the right part of the sentence as well, and then I will come up with what that particular word means. Basically, the context of that word. There is one more type of architecture which we have. Again, if you remember the transformer architecture, we have the left part and the right part, where left part is the encoder and right part is the decoder. So the GPT, the ChatGPT which they have built is a decoder only architecture, where they have only decoder, right? They don't have encoder in that. It generates one word at a time. like writing a story based on previous words only. Doesn't need to understand a full input. It creates the content. Real life example is GPT, generative pre-trained transformer, used for writing poems, chatbots, code generation. These are the use cases which we have for decoder only architecture. Now, how transformer builds sentences? Let's say GPT wants to generate a sentence. The dog chased. It starts with the dog, then guesses the next word chased, and then cat, maybe. It does this one word at a time, checking what it has already said and predicting what comes next. Think of it like playing a game of fill in the blanks over and over again. So basically what happens, it generates the text. It's learning as of now. So passing the various texts and trying to learn by doing a lot of filling the blanks type of exercise. Now, insight attention. So attention mechanism is again one of the important concepts which they have implemented in this transformer. So we'll try to get understanding of what's going on in the inside, the attention mechanism. So attention is a way for the model to focus on most relevant words in a sentence while processing language. For example, the girl put the book on the table because it was heavy. We need to figure out what does it refers to. Is it the book or the table? Attention helps the model decide by looking back and measuring which word has more importance or relevance to it. Right. So based on that, it will decide, okay, because the book is heavy, she is putting on the table. Imagine you are in a play, there are 10 actors on the stage. You are the director trying to decide which actor to shine the spotlight on during a key moment. Each word in a sentence is like an actor. Attention is like a spotlight that shines brighter on some words than others, depending on what you are focusing on. Right? So that is the analogy which you can think of while we are talking about attention. Each word in a sentence looks at every other word, including itself, asks, how important are you to me in this moment? Calculates a score for each word. This becomes the attention weight. The cat sat on the mat. If we focus on sat, it might give high attention to cat, low attention to the, on, etc. Output of weights like you can see at the below list. The is having 0.5, cat is having 0.7, sat is having 0.1, on is having 0.5, the is having 0.5, and mat is having 0.5. So the cat is getting the more spotlight because the cat is sat on the mat. So as we are focusing on the sat, so obviously cat is taking more priority. Now there is a concept inside the attention which is known as keys, queries, and values. So we'll try to understand this also as a layman what it means. Here is how attention actually works inside the model using a smart trick. Every word becomes three versions of itself. That means let's say I'm having one word of the sentence, so it has a three version. One is the key, how important am I? Second is the query, what am I looking for? And what is the value? What information do I carry? Then we calculate attention score. How well query of one word matches key of others. It's something like you can say as a layman, like a correlation, right? So we use those scores to mix the values and get final attention output. Let's take one analogy here. Let's say job fair words. Imagine a job fair where every word is both a candidate looking for the job and a company looking to hire. Now, step by step, how it works. Each word has a resume. That means each person has word is like we discussed, right? Each word is a candidate. So each word means each candidate. So each candidate has a resume that is known as key. It tells what the candidate has to offer. Right? So don't confuse with this word and candidate because we are considering word as a candidate. So each candidate has a resume. It tells what the candidate has to offer. That is the key. Basically, the property of that guy. Second is each word or each candidate also has a job description. That is the query. What kind of candidate it wants to connect with, right? So candidate is coming for a job for a Python developer. Query is also talking about Python developer. So that has a relevant word. That is a relevant candidate. But if let's say a candidate coming with a different knowledge, let's say Java knowledge, and the requirement is for Python. So in that case, there is no point of, or I can say there is no relation of that word or that candidate for that particular job. So that is the query, right? So basically key is nothing but the property of that candidate. Query is nothing but what type of job is what company is looking for. So they look around the job fair and try to find matches between job descriptions and resumes. The better the match, the more attention one word or one candidate gives to another. Once matched, they share ideas and details. That is nothing but values, like company onboarding, right? So basically, there are three things, as I mentioned. One is the key, second is the query, and third is the value. With this example, you must have understood that how important am I? Resume, right? So resume will give me the understanding about my profile, and that will help company understand how important this particular candidate is. Second is query, what I'm looking for, right? So basically, what company is looking for and whether I'm fitting on that or not. And third is what information do I carry? So that is nothing but once I join the company, I will have a discussion and that is nothing but the value. So that is the simple analogy of how attention works. There is one more concept of multi-head attention, which we discussed. That is many spotlights. Now, for example, I have a sentence and one word is actually coming from two words. So I have to spotlight two words, right? In Hindi, suppose I am writing something and let's say combination of two words is a one word in English. So I have to spotlight on two words. So that is multi-head attention. And again, spotlight means a lot of other things as well. Or I can say multi-head attention means a lot of other things as well, like understanding the grammar, the emotions, the nouns, the verbs, and a lot of other context. So transformers don't just run one attention spotlight. They run many at the same time. Each one focuses on something different. One might track grammar, one might track emotions, one might focus on nouns, one might focus on verbs, and so on. These are called heads, and each runs its own version of attention in parallel. Then all heads are combined to get a rich, multi-dimensional view of the sentence, right? So basically, you can consider it like a various spotlights on different angles I am trying to put it in, so that I'll get the information from that entire sentence. And based on that, I will try to come up with the idea that, okay, this is what it is trying to say. So inside this entire transformer, actually what is happening is that entire mathematics is going on and it's like complex mathematics, which they are trying to run it. So here is the summary what we have in the inside the attention mechanism. First is attention, focusing on important words. Second is self-attention, words looking at each other. Query, key and value, matching interest to decide importance. And multi-head attention is like many views at once, like grammar, emotions, and so on. Now, how transformer learns? Basically, the training phase, right? How the training phase works, how the transformer learns in this entire training scenario. So here you can see. Let's start with you as a kid. You heard some sentences from parents, books, cartoons. You guessed meanings from the context. When you made mistakes, someone corrected you. Similarly, transformers learn language by reading huge amounts of text like books, websites, and articles and trying to predict what comes next. It's having a human feedback. So basically, if you are aware of ChatGPT, it's like falling into RLHF, reinforcement learning with human feedback. So if something coming wrong, I can give the feedback and it will be considered as a negative reward. And based on that, machine will improvise. So training is like a school for a transformer. It reads billions of sentences. Its task is to guess meaning, missing words, or predict the next word. If it guesses wrong, it gets a small penalty that is known as loss in the machine learning or AI terms. It adjusts its internal brain wires slightly. Basically, then it will change the weights, right? If you're coming from IT background, you will understand that. If not, that's okay. You can just understand that uh, basically I'm understanding that, okay, this is wrong. So I'll keep that in mind. So I will be very much cautious next time that, okay, if this type of thing is happening, then I don't have to do this. I have to do that, right? So that is the idea here. Over millions of examples, it gets better and better. The cat drank the fill in the blanks, milk, book, table. The model might guess. The correct answer, milk, gives it a reward. Wrong answers help it learn from mistakes. It keeps doing this sentence after sentence. So that is the training phase which we are doing. We are passing multiple sentences. Machine will respond. If it is wrong, I will give the negative reward. If it is correct, I will give the positive reward. So machine will learn, okay, this is what I have to do. This is what I don't have to do. Now there is a concept of back propagation as well, which we discussed in the earlier sessions of artificial neural networks and all. So that is what happening here as well. After each wrong guesses, the model finds out how wrong it was. That is called the loss. Sends the information backward through all its layers. Adjusts its connection slightly to improve next time. The analogy here is like a student reviewing why they got a test question wrong, learning from it, and doing better next time. What kind of data do we use while training purpose? So they are using a lot of different public books, Wikipedia, novels, news articles, social media texts like Reddit, coding websites for codes, models like Codex, product reviews, frequently asked questions, forums. So they have gone through a lot of things and lot of sentences from these texts which they have got. The goal is to expose the model to real world language, tone, slang, structure, and facts. Because once I will give all the possible scenarios, then machine will learn better. Now, what does pre-training means? You must have heard about a lot of pre-training models. The model is pre-trained model and all those things. So that is what we are now trying to understand here. So pre-training is equal to teaching the model general knowledge of the language first, like giving a child all the books in the world, not focused on any one task, like example, translation or question answering, just helping the model understand how language works. Later, we can fine tune the model for specific jobs like summarizing or chatting. So basically, you must be seeing that a lot of models which are already built, we are creating the product on top of that because that model is already trained on huge amount of data. So it has a knowledge. Now I am giving my knowledge as well, and I am trying to train the model for my tasks. Right. So that basically that is known as something like a transfer learning concept. So in the NLP, it was not there earlier. And because of that, the challenges were coming in. But because of this transformer architecture, that transfer learning concept is also coming into picture. And because of that, I can actually use all the trained model and I can go and I can create my own products as well. Because if this transfer learning concept will not be there, in that case, every time when I will have to come up with my own solution, I have to train my model from scratch. And that will be a cost, that will be energy. And because of the transformer architecture, they are giving us that flexibility that whatever model is already trained, you can use that and you can customize that as per your need. And that is the power which we are getting from the transformers. And that is why it is like very much powerful thing which came up. in the field of machine learning and AI. And that is the reason you can see a lot of things are happening in this field. After training, the model is smart. After weeks of training, again, it takes a lot of time, right? So training is not just a small 1 hour or 2 hour job. It takes weeks and months. A lot of energy gets consumed because a lot of electricity is required. We have to cool the machines as well. So a lot of what do you say? Uh, Resources for cooling the machines, water and all also required. And because of that, China came up with a very brilliant concept of deep seek, where they don't need a lot of money for what do you say? They don't need a lot of energy basically because they made a change in the programming front, right? They are not using the heavy machinery and all. They are using the programming. They made a small change in the programming, and because of that, they have come up with the concept of deep seek, which was way cheaper as compared to OpenAI models. And at the same time, energy consumption is also less. So that is again a breakthrough which they have come up with, and people are now thinking on those lines as well. So after the weeks of training, the model knows grammar, understand common facts, has a feel for tone, emotion, style, can mimic human like writing. It's like a student graduating from the language school. Transformer in the real world. So transformers are multi-talented. They are not just good at one thing. They are used across many fields, from writing and understanding text to translating languages and even generating creative content. Example are Siri, Alexa, Google Assistant. These are the examples which we have. Transformer like GPT and BERT power visual assistants and chatbots. How it works? When you ask a question, the model reads the entire sentence and tries to understand what you need. What it does, it generates a relevant answer or helps you complete the task. Right? That is what this particular thing does. Example is, hey Siri, what's the weather like today? So Siri uses a transformer model to understand your request and give you a weather update. Language translation. Google Translate. Transformers like T5 and Marian MT have revolutionized language translation. How it works? The model breaks down sentences into tokens and uses its pre-trained knowledge to translate between languages. What it does not just translate word by word, but understands the meaning of entire sentence. Example, hello, how are you? From English to Spanish, and what is the outcome is coming in. Hola, como estás? Right. So that is the language translation which we are using. Text summarization. So these are some of the use cases where transformer can be used and it is using in the real world. Summarizing news articles, research papers, or reports. Transformers like BART and T5 are excellent for at summarizing long texts. How it works? The model reads the full text and then condenses it into a shorter, meaningful summary. What it does? It used to help quickly get the gist of long documents without reading everything. Example, you can give a long news articles and model will give you a short version of the key points. Sentiment analysis, analyzing customer feedback or reviews. Transformer like BERT are great at understanding emotions in text. How it works? The model reads reviews, social media posts, or customer feedback and determines if the tone is positive, negative, or neutral. What it does, it helps businesses track how customers feel about their products or services. A company might analyze hundreds of reviews of a new product to find out if people are liking it or disliking it. Text generation for creativity, writing stories, poems, or generating creative content. Transformer like GPT are used for generating creative content from stories to code. How it works, the model can generate text based on a prompt. It helps writers, artists, or marketers create new content quickly. And you must be seeing these days, like people are using this quite extensively. You ask GPT write a short story about lost puppy. The model generates a complete story in seconds. Healthcare assisting doctors, analyzing medical texts and helping with diagnosis. Transformers like BioBert and MedGPT are used to help doctors with medical research, patient records, and diagnosis. How it works? Model analyzes medical papers, clinical notes, and patient data to help identify patterns, diseases, or even recommend treatments. What it does, it helps doctor make informed decisions quickly and accurately. A doctor can use a transformer model to analyze patient history and suggest possible diagnosis based on symptoms. Code generation and debugging. Those who are coming from the IT background, they must be using this quite extensively now. Writing and debugging code. Transformers like Codex by OpenAI can write code based on natural language descriptions. How it works? The model reads your description. Example, write a Python script to sort a list of numbers and generate working code. What it does, it helps developer write code faster and even debug errors. You can create a function that finds a factorial of a number. The model writes the Python code for you. Personalization and recommendations. YouTube, Netflix, Amazon product recommendations. Transformers are used to personalize content for you based on your past behavior. How it works? The model analyzes your preferences and predicts what you might like next based on text data, views, or purchases. What it does, it recommends products, movies, or videos that match your interests. You watch cooking videos on YouTube, it recommends more recipe tutorials for you to try. Finally, the last part, the future of transformers and what's next. Transformers are already powerful, but there are still many ways they can be improved. Here are some of the key areas where transformer models are expected to evolve in coming years. Let's talk about that. Better handling of long texts. Current challenge which they are having is transformers struggle with processing long documents due to the token limit we discussed in the earlier module. They can lose context when the text is too long. Future innovation, long range transformers. So new models like long former and reformer are designed to handle longer texts more efficiently by reducing memory requirement. Memory augmented models. We might see models that can remember and retrieve information from past interactions or documents, allowing them to handle longer and more complex context. What this means, a transformer could handle entire book, research paper, or long conversation without forgetting key information. So although transformers are good, they are handling long text better. But when it is coming out to be very huge text, huge is as in like it's a huge number, right? I'm talking about. So in that case, it is still having some challenges which we can take care of, which is like uh, the next thing which will definitely happen. Multi-modal transformer, text, images, and more. Current challenge which we have is most transformer models focus on text, but the world around us is multimodal. Like we have the text, images, videos, sound. Now, what does the future innovation look like? Multimodal transformers will understand multiple types of data at once, combining text, images, videos, and even sounds. Example, imagine a model that can look at an image and describe it in words, or watch a video and summarize the action or dialogue. What this means, transformer could be used in applications like video editing, autonomous vehicles, or multimedia search engines. So that is the use case again, which people will work on. Improved fine tune with fewer data. Fine tuning a model for specific tasks often requires lots of data and computational resources. Future innovation, few short learning. Models like GPT-3 already do few short learning, understanding tasks with only a few examples, but this will get better with models being able to adapt quickly to next task even with limited data. Meta learning models may get better at learning how to learn, adjusting quickly to new environments, tasks, or languages with minimal data. Transformer could become smarter and more adaptable using less data for specific tasks, which makes them more efficient and accessible. Ethical AI reducing biases and fairness issues. Transformers can inherit biases from the data they are trained on, leading to unfair or biased outcomes in applications like hiring, law enforcement, or healthcare. Future innovation, bias mitigation. Researchers are working on methods to reduce bias in models by using more diverse training data and creating better ways to detect and eliminate bias. Bias, as in you can understand, for example, let's say I want to give promotion, and as I already trained on a lot of male data, my model will be biased and it will always give promotion to the male, and that is wrong, right? So that is what we have to take care of. Future transformers will likely include more robust ethical guidelines to make decisions that are more fair, inclusive, and transparent. We will have more ethical AI systems that are fairer and less likely to cause harm in sensitive areas. More efficient transformers, less energy, and more power. So as I mentioned, DeepSeek is already came up with the interesting concept, but a lot of things are again we are working on. So current challenges, transformer models like GPT-3 are massive and require a lot of computing power and energy, which raises concern about their environment impact. Energy efficient models, new architectures are being developed to make transformers more efficient, reducing the energy cost of training and inference. That is again, as I mentioned, DeepSeek is one of the examples. Distillation, model distillation, the process of making large models smaller and faster will continue to improve, resulting in smaller models that perform just as well as the larger ones. Basically, distillation is nothing but whatever model, the big model we have trained, I'll just create a copy of it with a smaller size and I will use that. Right. So that type of thing is also happening, which is as of now not giving that good accuracy. But that is what they are working on. That if you are creating a shorter model from the bigger model, that should also give the better accuracy. So that is what they are working on as of now. Transformer could become greener and more accessible, running on less powerful hardwares and using less energy. Universal transformer, one model for everything. Current challenge, different tasks like text generation, translation, summarization, etc. often requires different models. Universal transformers, a single transformer model that can handle any task just by changing the prompt or task description. These models would be versatile, handling everything from text generation to image captioning and more, all in one place. There would be one model that could do everything, reducing the need for multiple specialized models. Real-time interactive systems. While transformers work great for tasks like text generation, they still can't handle real-time interactive scenarios like real-time conversation or decision making during live events. So real-time transformers, while we will see more interactive AI systems that can respond and adapt in real time, handling conversations or tasks as they happen. These could be used in applications like customer support, live event summaries, or even real time language translation. AI could react instantly to changing conditions or conversations, creating more seamless interactions. So these are the things which we are working on. People are working on, obviously, and obviously these things will come in. They have already done a great job in last how many? Almost 8 years, because in 2017 the transformer paper came in, and after that they have made a lot of interesting innovations based on that. And in just 8 years, you can see a lot of things happened. And they are actually doing great things, right? You can generate the images, you can generate the videos, songs, musics, everything is happening seamlessly. So all these future innovations which we have discussed also going to happen. There is no doubt on that. and there can be a chance that it will happen quickly, right? So people are working on it, and you will see the changes. So that is about the idea about how the transformers are and what is transformers, how the architecture is. Again, as a layman, as I mentioned, this is more like a people who are having zero knowledge on AI world. So this session is basically meant for them, and that is what we have discussed. And I hope this makes sense. At least you got the idea that what transformers are. And actually, this is the big thing. This is the only thing which is actually going on in whatever thing you are doing as of now in your day-to-day task with the help of AI. Behind that transformer is there. Right. So that is the idea. That is what I want to discuss. Any doubts you have, you can ping me on the chat. We can have a discussion. All right. Thanks for your time. We'll see you in the next session. Have a nice day.